Hello guys, welcome to Scenario Based Hacking Part 4. In this video, we will look at a scenario in which both the operating system and the softwares installed on the victim computer are fully patched. However, there is still no antivirus and the victim is behind the NAT. So how do we take up this scenario? Well, because all the software is patched, it would not be possible to target any specific software. This is where we can use a combination of social engineering and a custom Trojan. Now, you can create a Trojan by multiple means. You could even code one. However, in the essence of valuing time, the easiest way to create a Trojan binary is by using a combination of MSF payload and MSF encode. In Metasploit Megaprimer Part 14, I talk in great depth about this, so please have a look at that talk. I will not be repeating many of the things which I have already taught there. So, once this Trojan is created, how can we deliver it? Well, the user might end up downloading the Trojan from the web somewhere. We might go ahead and email it to him, or you might give it to him on a USB. Alternately, it is also possible to do a man-in-the-middle attack using DNS, cache poisoning, or even ARP spoofing if we are on a LAN. So many possibilities. The setup remains the same. VMware 1 is our attacker machine running Backtrack, and VMware 2 is the victim machine running Windows XP, which is behind a virtual NAT device. So let's look at how to exploit this setup. This is our Backtrack machine, which is up and running, and we are connected to this machine using PuTTY. This is the Windows XP machine, which is the vulnerable machine. So the first thing we will do is actually go ahead and create a exe containing our payload. For this, we will use MSF payload utility, right? So the first thing is actually to give it the payload. We'll use the Metapredator reverse TCP and then give it the options. This is the attacker IP address. Now, if some of this is not familiar, I would request you to visit part 14 of the Metasploit Megaprimer. And we want output in exe format, which we will actually give to create an executable, reverse tcp.exe. Looks fine. We'll wait for a bit, and now if you notice, the executable has been created. Now we'll copy this executable to our web folder using which the victim would access it. Then what we do is, before we actually go to the victim, in Metasploit we'll actually use the multi-handler to actually handle the reverse TCP payload. Okay, so our handler is now listening. Let's go back to the victim machine. And the victim machine is browsing the web, and we are on our vulnerable page. Let's go ahead and download the exe. The exe is currently there. Let's run this exe, and you will notice almost immediately we have a Metapredator session on the attacker machine, right? And this exe is running in the background. So if we actually look at the task manager, you clearly notice that the metapreter reverse tcp.exe is running in the background. Right? And once we have a metapreter session, I guess we can do tons of stuff which we've already gone through in enough detail in the Metasploit Mega Primer. So let me just exit from this prompt, start our handler again. Now, one of the issues is that this is a binary program which a user would have to download and run. Right? So this does not look very convincing. So what we can do now is to make this more convincing to the gullible user. We will take an existing executable on the system which the user might use and trust, and then actually go ahead and trojanize it with our payload. So what we will do is we will use notepad.exe, which is a very common program on Windows systems. And before we use it, let's actually have a look at the usage for MSF encode. I guess we'll have to figure out the specific encoder, which would be Shikata-ga-nai. Now, as I said, if any of this is confusing, go visit the Metasploit Mega Primer. We've covered this in enough detail. So I'll use my previous prompt, ensure the output is in raw mode, pipe this to MSF encode. The encoder I will choose is Shikata-ga-nai. Number of times to encode is typical 4. The output, what we want, is basically in exe format. And the name of the output file, let's say notepad trojan.exe. We need to mention an executable template, which is notepad.exe from the current directory, and we would want that the template keep working, which actually means notepad would run and our payload would run as a different thread. Okay, now let's run this command. Hopefully we've given all the options that are required. Okay, so I think there was some issue, which is the path of the executable. Let me actually give the path properly and rerun this again. Awesome. So now we have the notepad trojan exe file in our current directory, and we will just copy this to our web directory. Now we go back to the victim. We already have our handler running. Go back to the victim, refresh this page, download notepad trojan. If you notice, this looks exactly like Notepad, right? And when we execute it, actually the functionality of Notepad is there entirely. There's no problem at all. But in the background, if you notice, a metapreter session has already opened because of our payload executing, which is awesome. We've gone ahead and Trojan this perfectly, right? So if we go to this, actually do a get UID, we are Vivek. If we do a get PID, we get our PID, do a PS 2732, we are actually notepad trojan.exe. So one of the good things at this stage would actually to be migrate away to 2876, which is explorer.exe, just in case the file is closed or something else happens. Right? But this is absolutely awesome, as you can see. We've already demoed this in the Metasploit Mega Primer. Just wanted to show you how a Trojanized program can actually fool a gullible user much more simply. So coming back to our presentation, well, what we did was we created a malicious executable, which was a lookalike of one of the programs the user has used. And after that, we could use any one of the methods of delivery, email, web, some other social engineering technique, or a man-in-the-middle attack and actually push the program inside, right? So, well, what did we learn in this scenario? That even if all the software is patched, it is still possible to create a malicious executable and fool a gullible user into running it. Well, that's all for this video. Now we'll go on to more complicated scenarios. Thank you for all the comments and mentioning the additional scenarios. I'll try my very best to address each and every one of them.